section, there's just a lot of introductory vocabulary we're going to use today. It's all about triangles. We are going to classify triangles. Is it isosceles, scaling, equilateral, right, acute, obtuse, a lot of that vocabulary words. Probably the worst thing you have today is this first warm-up problem, because we're going to have to use this today. And I put it on the board over there in case maybe you forgot. You have to do the distance formula again. So you might want your calculators. Get out your calculator. You're going to need a calculator today, because you do have to do distance formula 3 times. 3 times. I counted for a minute. So grab your calculator. I'm going to start setting it up here. Now, as always, you guys are great with distance formula. It's been a while, though, since we've done it. That's from a previous chapter, so let's just go over it quick again. I like to label the points. I know my -3 is like off the board there a little bit, but I like to label the points. You don't have to. And again, I'm just plugging the numbers in the formula. x2 minus x1. So 0 minus -4. Yeah, I know that's a plus. I'll make it a plus in a minute. I'm just setting it up. And then I've got my y2 minus y1. So -3 minus 9. Let's make this a plus. Okay, I'm going to give you a second. Type that in just as it appears. You shouldn't need any more work than that. You will get a decimal answer. Round to 1 decimal place. Let me give you a second. All right, you should have it. What do we have for a decimal? Anybody? 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 12.6 for the win. Okay. So like I said, distance formula is going to come back up today. Okay, it's been a while since we've done it, because we're going to need it tomorrow too when we're calculating the lengths of the sides of some of these triangles. So just wait for it. Now, area of a triangle comes up again this chapter. We've done it a little bit way back in chapter 1. It's been a while. Do you remember the formula for area of a triangle?
1/2 base height.
You got it. So, and they give you everything. 1/2 base height. I know some of you like base height over 2. It's all the same thing. Doesn't matter. So 1/2. Our base is 7. Our height is 10. Now, I think we can mental math this, people, because you have half of 70. What's half of 70? 35. And let's throw a label on it. Centimeters squared. Good. So we're going to calculate area of triangles again this chapter. We've done it. We've seen it. It's nothing exciting. I just thought we might need a refresher on it. All right, let's get into all the good triangle stuff here. Now, definition of a triangle. Now, triangle, of course, 3 sides. I know you're shocked by that. A polygon with 3 sides. And remember, we've seen the word polygon before. That just means it has straight, not curved, straight sides. Like a quadrilateral, 4-side, hexagon, octagons. We talked about all the different things. Now, I think you'll like this. To name the triangle, there's no crazy, remember all those details of chapter 1 on naming rays, planes? No, easy. All you have to do is draw a little triangle symbol, and then it's up to you what you want to call it. ABC, BCA, CAB, I don't care. I'm going to be lame and go ABC. You just have to list the 3 vertices. That is as wild as the naming gets on a triangle. You can't beat it in this chapter, okay? So, you have to classify triangles by 2 different things today. You have to do it by the sides and then by the angles. Now, you might know a lot of this already. Like, I have a good feeling you probably have heard the word scalene before. None of the sides are the same. Isosceles, of course, 2 of the sides are the same. This word you might not know. Equilateral. All the sides are the same. Now, my other class was worried about spelling. Do we have to spell these words perfectly? I would like that we would spell them perfectly. We should be able to spell equilateral. I like some of you shaking your heads no. But at least can I ask that we spell it close enough I can tell what you mean? How's that? Can I ask for that? Okay, that seems reasonable. Now, you also have to classify by the angles. Now, acute. We've seen the word acute. Less than 90. All 3 angles are less than 90 degrees. Exciting stuff, I know. Right triangle, you shockingly have a right angle in it. Obtuse triangle. Obtuse, of course, over 90. Here's your obtuse angle right there. Now, if it's equilateral, I just like saying that word, it's also equiangular. all three angles are the same. So you, and you'll see some pictures, I see some of you already doing them, have to classify, you're going to have 2 words for each triangle. Classify by the sides and by the angles. So of course, as always, the first section is always just a bunch of vocabulary. So here we go. Classify by the sides. Well, let's start with that. 2 congruent sides, isosceles. Maybe we should have like an extra credit spelling quiz over the words. That just was a great idea. I gotta remember that one. Okay, now by the angles. Acute, right, obtuse, equiangular. What are you using? Right, it's right angle, right. I know, exciting stuff here. That's a T. Okay, number 2, 3 congruent sides. So these are all the fun spelling ones for you. Equiangular. And if all the sides are the same, it's also equiangular. Equilateral, equiangular. Those always go together. We need both of them. So equilateral. Right underneath, I guess. And then equiangular. Gosh, when's the last time you guys did a spelling quiz? I can't stop thinking about that now. That's one of my better ideas today. Okay. For sides, what do you got for this one? Scalene, isosceles, or equilateral? Isosceles, 2 congruent sides. Why is this on here? Just to mess with your minds, okay? There's only 2 congruent sides, isosceles. Okay, angles. Acute, right, obtuse, or equiangular. What do you notice about all 3 angles? They're all less than 90, so acute. Got it. So, first part of the homework, that easy. There's just some pictures of triangles, and you just have to name them by the sides and, of course, by the angle. Any questions on the front page of the notes? Too easy. Too easy. Okay, here's where it gets bad. In the sense of, we actually have to do some work now, my friends. Classify by the sides, then determine if it's right. Okay, all right. Here's the thing. I'm looking at the triangle. Do we think it's right? Let's start with the right part. Do we think it's right? I see some maybe, sort of, I don't know. I'm looking at this angle. It kind of looks right. Agree with that? But I need like facts, proof, math, obviously. So here is a throwback. We're going to make this easy since we're on a graph grid. A throwback to your quiz from yesterday. If you have a right angle, you have perpendicular lines. And what is significant about the slopes of perpendicular lines? Opposite, and they're opposite in signs, positive, negative. What else? I see you guys, flipping it. The fractions are flipped. So I'm not going to get dramatic here. Well, maybe I might get dramatic. You know, I like to get dramatic. I'm just going to count the slopes, and I'm going to see if these slopes are opposite reciprocals. I'm going to do the slope from P to O. I'm just literally counting rise over run. So P to O, down to right 1. I'm going to get fancy and make it -2. Okay, then I'm going to do the slope from O to Q. So the slope, O, Q. Same thing, I'm just going to count the rise versus the run. Okay, I'm going to move over closer to the graph here so I can see it. So from O to Q, up, 1, 2, 3, right, 1, 2, 3, 4, 5, 6, 3 over 6. Which, of course, good mathematicians that we are, we're going to reduce 3 over 6 to what? 100. Okay. Now, are these slopes perpendicular? They are opposite reciprocals. Is that a right triangle? Do you have a right angle? Yeah, we have perpendicular lines, hence we have a right angle. So I'm going to say yes, it is right. And just when you think you're done, you're not, okay? Because then it also wants, we got to talk sides. So I'm like, oh gosh, okay. Is it scalene, isosceles, or equilateral? Well, I'm going to rule out equilateral. Do these look the same? No, it's not equilateral. I'm kind of wondering though, is it isosceles? Like, are these guys the same? I can't just try to like Hail Mary it and count it. I see some of you already looking at the whiteboard over here. We're going to get exact and do math I'm going to calculate the distance formula. I know this is the worst part of the day. The distance formula and see if those two sides are the same. I don't just want to guess and do a Hail Mary here. So I'm going to first do the distance for P to Q. This is why we did that warm-up distance formula problem. You're welcome. Okay, so, but, I mean, it's not awful. It's not awful. Would you rather do distance formula or proofs? Okay, thank you. I appreciate that. Okay, so x2 minus x1, 6 minus -1. Yes, I know that's a plus. And then I'm going to have y2, 3 minus 2 squared. Okay, let me give you a sec. Punch that in. See what you get for a very lovely decimal answer. I feel like we need some Jeopardy music on. What do we got? Anybody? Somebody? Thank you. So now, I know this is just the time-consuming one. We have to do the distance formula from O to Q and see if we get 7.1. I mean, they look kind of close. I don't know. Let's do it. So again, I'm going to do my x2 minus x1, so 6 minus 0. And I'm going to do my y2 minus y1, 3 minus 0 squared. Now, a course pro tip, do you really need the minus 0 here, people? No, let's just do 6 squared plus 3 squared. Less keystrokes, right? Is it 7.1? Is it close? It's not, right? What do you got for it? 6.7. Ah, so they're close. They're close. 6.7, 7.1, but they're not the same. So now we just have to classify it. None of the sides are the same. What do you call that? Scaling. Yeah, I heard it. Scaling. That was pretty fun. Okay, so I'm going to be honest. This is the worst thing you have to do today is the distance formula to check the sides. That's as bad as it gets. Everything else is pretty straightforward. Nothing too complicated. Now, this to me is super wordy for something that to me, of course, makes common sense. We are going to start finding the measures of interior angles and exterior angles. Interior, I know you're going to be shocked by this, are angles inside the triangle. So you can see my little light red, pinkish colored corners there, inside. And then we are going to talk about exterior angles, this chapter 2, and exterior angles are on the outside. I know that's shocking stuff. Who would have thought it? So let's start with interior ones. The sum of the measure of the interior angles, 180 degrees. That's what you have to fill in on the blank. We will use that a truckload in here. So all 3 interior angles always total to 180 degrees. So make sure you get that 180 filled in on the blank, okay? Under triangle sum theorem. Everything's so worried. I think everybody's got it. Okay, find the value of x, then classify the okay, so let's first find the value of x, then we'll get into the classifying. Now again, all 3 angles, the 40, my 4x, it doesn't matter which angle you started with, I just started with the bottom left because I don't know, felt like it, and then my 3x, they should all total 180 degrees. So now we're just going to do a little bit of algebra, of course. 4x, 3x, let's combine it. You guys are very good at solving equations. I'm also going to go ahead and save us some writing. Let's subtract 40 over here. What's 180 minus 40? 140. X is 20. We're solving equation machines. Okay, we found the value of x, great. Then it says classify it. They might even today on the homework too, just to kind of give you a heads up on the directions, they might even ask you to give the measurement of the other angles. AKA, put your 20 in here. 4 times 20, 3 times 20. I know this one doesn't specifically ask for it, but they might on the homework, so I'm just reminding you how to do that. Now, yeah, 40, 80, 60. Would you classify this as acute, right, obtuse, or equiangular? Acute, right, obtuse, or equiangular? Acute. They're all less than 90 acute. Got it. Any questions in there? All right, flip the page. We're cruising right along, everybody. All right, exterior angle. Because, I mean, we're not doing any more interior. That's as wild as it gets, people. Exterior angles. This one's a little tricky because you got to kind of memorize it. So this outside angle, the outside of the triangle, equals the sum, this is very wordy, the sum of the two, here's what you gotta fill in on the blank, this last line, two non-adjacent interior angles. Ooh. Non-adjacent, they're not next to each other, okay, interior inside angles. So you might be, dear Lord, what does that all mean? Non-adjacent interior angles, it's these far ones. Okay. So the outside angle equals the sum of these two far away angles. That's what all of that wordiness boils down to. So you can see here they got angle 1 on the outside, A plus B, the two far away ones. You just have to memorize that, okay? Such a word. Okay, find the measure of angle, JKM. So JKM, my outside angle, this guy. So outside, exterior. I'm gonna write that down first. Equals the sum. I'm going to add the two angles furthest away from it. So I'm going to add up x and 70. So there's the setup. Okay, the rest is easy. We can solve for x. I'm going to subtract x over. And while we're at it, you probably already have the answer here, I have a feeling. Add 5, x is 75. Now, as always, this is such a teacher thing to say, make sure you read the directions. They want that angle JKM. So I would just do this all in my calculator. We need to put 75 in here. What am I writing to? 75. So in my calculator, I wouldn't even do any work. I would just do 2 times 75, or mental math it. What's 2 times 75? 150, 150 minus 5. So that is your final answer. So, I know, this is such a teacher thing to say, but read close on the homework. Some just say solve for x, some ask you for an angle measurement. So just make sure you answer the final thing. I know. All right. In a right triangle, the measure of one acute angle is 4 times the measure of the other acute angle. Find the measure of each. Okay, fun, interesting. Now, in a right triangle, so they're talking about interior angles. All 3 angles inside a triangle add up to what? All 3 angles add up to, don't all yell it, 180, 180. So we're going to add our 3 angles. I'm just going to put 3 blanks. Okay. Now it says the measure of one acute angle is 4 times the other. All right. Well, I'm just going to make one of the angles x. Use x for my variable. The other one is 4 times that. So what's another angle? 4x. Now, what's the third angle? 90. It is a right triangle, so 90. Well, that's easy to solve. 1x plus 4x, 5x. Let's subtract 90 off. In your calculator, 90 divided by 5. Punch it in. What do you got? 18. Okay. Now let me see if that's all they want. Let me read it. Find the measure. Oh, okay. All right. Measure of each angle. So 1x is going to be 18, one angle. The second one, what's 4 times 18? Do it in your calculator. 72. Now, what's the measure of each angle? I mean, clearly our third one was 90. There we go. So we've got them all. Love it. So we're saying distance formula today on those distance formula problems. The rest of the stuff's not so bad. This is just really for fun, though. Find the measure of each angle 1 through 8. Now remember, okay, I'm going to give you a hint because, God, I just love it. Geometry, the gift that keep on giving. It's a free-for-all. You can use vertical angles in this picture. You can use linear pairs. Linear pairs add up to what? Linear pairs, 180, 180. Okay, so my advice, my pro tip is, I just kind of, I don't know, I like to do it on the picture. I just label on the picture. Now, I see too we have some triangles. And we know all three angles in a triangle add to 180. Okay, so let me give you a minute. All right, let's do it. So I said I would do 8 first, because if this is 40, what's 8? Linear pair. So they add to 180. Okay, I'm just going to label it 140. And then I said, you know what, I would do 1 next. Because all three in a triangle should add to 180. So you have 90 and 40. What's 90 and 40? 130, you need how much more to get to 180? 50? If 1 is 50, what's 3? Why? You're right, but why? Because what type? I love the answers. Because I said so, because they're the same thing. Can we maybe give me a specific name of this type of angles? What are the angles that make the X called? Vertical angles or vertical angles? Okay, all right. All right, what's 2? 130, because you have another linear pair. Vertical, 130. We're crushing it. Okay, we got another triangle here. We can get 5. I'm doing 5 next. 5, 50, and 90. So 50 and 90, I'm at 140. So 5 needs to be what? 40. If this is 40, this is 140, because they have to add to 180, linear pairs. And last but not least, I need 7. What do you got for 7? 7, linear pair, 90. 90 and 90 makes your 180. So I just find it easy. I just write on the picture what they are. I don't get crazy enough for them to do all that fancy stuff. All right, any questions? How I got any of those? No proofs yet.